Solve the problem using a system of equations. Two cars start from points 420 miles apart and travel toward each other. They meet after 3.5 hours. Find the average speed of each car if one travels 30 miles per hour slower than the other. Well, we've completed step one. We've read the problem carefully. In step two, let's define our variables. Let x equal the speed of the faster car and y the speed of the slower car. Now let's move on to step three, and let's try to write a system of equations. I'm going to use a table to help me organize my information. And also, let's make a note that d is equal to rt. Distance is rate times time. Now let's complete this table. We've defined the faster car's speed as x and the slower car's speed as y. We're told that after a period of 3.5 hours, these cars meet. So the time amount is 3.5 for both cars. Our last column, distance, is rate times time. So the faster car's distance is x times 3.5, or 3.5x. The slower car's distance is 3.5 times y. I'm going to add another piece to this. We're told that these cars start at a distance of 420 miles apart. After 3.5 hours, they meet, so they've covered a total of 420 miles. Now we're ready to write our system of equations. We're given that the faster car travels 30 miles per hour faster than the slower car. So x is a larger number, and the difference, x minus y, then is equal to 30. Let's call that equation 1. Equation 2 comes from our last column, where the sum of these distances is 420. So write 3.5x plus 3.5y is equal to 420. And let's call that equation 2. Now I'm going to use an elimination method to eliminate the variable y. Let's do that by fixing each of these equations. Let's create a coefficient of 35 and negative 35 in equations 2 and 1 respectively. So let's multiply equation 1 through by the number 35, equation 2 through by the number 10. Here we go. So equation 1 becomes 35x minus 35y is equal to 1,050. Again, that was 35 times equation 1. Equation 2 becomes 35x plus 35y is equal to a 4,200. And that was 10 times equation 2. Now we're ready to add these equations together. Our y variable cancels. Up front we get 70x, and that's equal to a 5,250. Divide both sides by 70 to get x is equal to 75. Now x represents the speed of the faster car. Y is the speed of the slower car, and we're given that that rate is 30 miles per hour less than the 75. So y is 75 minus that 30, or a 45 miles per hour. Let's state our answer very clearly. The faster car travels at a rate of 75 miles per hour. The slower car travels at a rate or speed of 45 miles per hour. As a last step, let's go ahead and quickly check these values. Notice number 1 that, yes, the difference is indeed 30. That satisfies equation number 1. And equation number 2 is 3.5 times x, 75, plus 3.5 times y, 45, indeed equal to 420? Well, multiplying here, we get a 262.5 plus a 157.5, and those do indeed sum to 420. Therefore, we've got a true statement, and we feel very comfortable then with our solutions. Faster car, 75 miles per hour. Slower car, 45 miles per hour.